Hello, everyone. So, you remember a few videos ago, we were looking at the number nine. We saw how we can um, get a multiplication table for any number that ends with nine. And why did we do that? We saw that that would help us or help some students who have trouble with long division. Today, I'm going to show you how to do it with 8 and 7, for example. We can do 8 and then we see if we have time. If it's not a long video, we can do it 1 for 7. 6 would be similar once you get the pattern. And then we will find that if you want to do it for numbers that end with 1 through 4, you pretty much will use the opposite strategy. 5 is the easiest because it works. You can use either strategy. So, um, before we start, I use my calculator and I multiply the number that ends with 68, by some other, random number, and I ended up with a result. So excuse me, what I'm going to do now is to tell you I'm going to divide 358,632 by 68. Before doing that, I have to create a table for a multiplication table for 68. 68 times 1 times 2 times 3 and so on and so forth. So we know that 68 times 1 will give me 68, then times 2 times 3 times 4 times 5 times 6 times 7 times 8 and times 9. Remember what we said when it was 9. We said for the left-hand side, you start with 9, and then you drop 1, so 8, 7, 6, up until you reach 1. With 8, notice 9, we dropped by 1. 8, you drop by, if you said 2, then you got it. And that's a game I used to play with young kids to teach them math, and we created a game called the game of 10. So when you say 7, they respond by saying 3 when they know that 7 plus 3 is 10. And that helped them with addition and subtraction later. It became much easier if you play this game. So 8 is 2. So we start subtracting 2. So 8 becomes 6, the 6 becomes 4, the 4 becomes 2, the 2 becomes 0. Once you hit the 0, as you might have expected, we assume it's a 10, not a 0, so that we can subtract another 2, and we get back 8, 6, 4, 2. Okay, remember what we did with the 9s. We said the 9 had the tens digit is 0. So we add 1 to that and we keep adding 1 as we go down. That's why we had 9 and then 18 and then 27 and then 36. And then we said if it's a number higher than 9, like 49, you keep adding 5s. If it's 79, you keep adding 8s. Same thing is here with a slight difference. The tenth digit is 6, so I'm going to add 7. 6 plus 7 is 13. 13 plus 7 is 20. 20 plus 7 is 27. 27 plus 7 is 34. Once you go below the 0, the next time you drop from the 0, you only add the 10th digit, not one more. So here I was adding one more than the 6, which is 7, 7, 7, 7. But now I reach the 0. So this next time I'm going to add only 6. And then I return back to adding 7. 34 plus 6 is 40, then 47, then 54, then 61. And I'm done. By the way, same thing with 7. If that number will end with 7, I will do the same thing, but I will be dropping by 3s, not by 2s. So let's go back to our problem and see. I want to divide by 68, and since 35 is less than 68, then I will pick the first 3 digits. 358, you go down until you find a number that is the first number you encounter that is less than or is bigger than 358, which is that. So you cannot reach the 6, you stop at the 5. So you say, okay, so the first digit is 5. 5 times 68 is 340. 340. So you subtract 340, you get 18. You bring down the 6, 186, 186. Oops, it's between 136 and 204. So it's 2. 2. 2 times 68 is 136. You subtract 136, so you get 50. You bring down the 3, 503, 503, 503. Oops, between 7 and 8. So I enter 7. 7 times 68 is 476. You subtract, you get 27. You bring down the 2. 272 is 4. 272 minus 0. We are done. So the answer, I'm sorry. Yeah, I could have added the 3. 3,58632 divided by 68 equals 5,274. Three five eight 632 divided by 68, and you get 5274. And that's basically it. Really, you should already be getting that. So let's pick, I'm going to pick another number that ends with 7 and multiply it. Okay, so the next one, we make it harder. I want to divide 785,368 by 127. So we need to develop a table for 127. 127 times 1 is 127. Times 2, times 3, times 4. So what I'm saying is that we change the division number into addition, really. Basically, you are adding the tens here and subtraction for the ones digit, which makes it easier for students. After that, when they grow up, I mean, they can do it, the long way or the traditional way. But here, because we realize some students have trouble, many that I met were talking about, long division, we don't like it. And I say, okay, let me start to think to develop a new methodology. Again, the 7, when I say 7, you say, yes, 3, because we are dealing with numbers that add up to 10. So I'm going to drop by 3. 7 minus 3 is 4. 4 minus 3 is 1. Oops, I reach a 1. So I'm going to assume it's 11. Take 3 from 11, you get 8. Take 3, you get 5. Take 3, you get 2. Oops, 2 less than 3. So I'm going to assume it's 12. Take 3 from 12. Take 3 from 9. Take 3 from 6. So I ended up with the ones digit. Now I go to the rest of the number. I have a 12. You say we used to use 2 digits, so we say the tens digit is 2. Now here we say the rest of the number, or the tens and the hundreds, is 12, right? So I'm going to add 13. 12 plus 13 is 25. Plus 13 is 38. Uh-oh. 1, meaning I'm going to drop below the 0 the next time. So the next time I'm not going to add 13, I'm going to add only 12. So I'm going to get 50. Then I'm going to return back to adding 13. 63, 76, 2. So I'm going to drop below the 0 next time. So I'm going to add only 12, 88. Then I add 13, 101. Then I'm going to add 13, 114. I'm done. Done with the tough part. In fact, the next time, it's the very easy part. We're going to use the first 3 digits, 785. 785, 785 is higher than 6, but less than 7. So I start with 6. 6 times 127 is 762. Notice that these, if you were not doing that, you have to multiply it. We already did that in an easier way. Subtraction and addition. Subtract that, you get 23. Bring down the 3, you get 233. Oops, it's between 1 and 2. So I'm going to enter 1, meaning 127. Subtract, you get 106. Bring down the 6, 1066. So it's between 8 and 9, right? So you enter 8. 8 times 127 is 1016. Subtract, you get 50. Bring down the 8. 508 is 4. So the answer is 6184. You can say 785,368 divided by 127 equals 6,184. Use your calculator. 785,368 divided by 127. And the answer, of course, is 6184. I hope this was an easy and a light session for you. Again, I don't think I need to do one for the 6 because you will get it. Or maybe we'll do one in the future. We take 5 and 6 because 5 is so easy. And then we'll finish this series by looking at numbers below. So the ending number is, instead of being 9 or 8 or 7, it would be 1 through 4. In that case, we'll use the exact opposite. And you will see why. I mean, notice that adding 9 or subtracting 1 is the same thing, regardless of the tens. I mean, if I have a 7 here, I can drop a 3 to make it 4, or I can add a 7 to make it 14. So you see that these two numbers, sometimes it's easier to subtract when the number is high, because now I need to subtract 3. But if it's 2, for example, why would I subtract 8? I would add 2. But by adding 2, there would be a slight difference between where I should add only the tens, or I should add one more than the tens. That's what we are going to discuss and try to clarify it. It's really very easy. Okay, thanks for your listening and or watching, I should say. And I hope to see you soon. Thanks. Bye.